Okay, so now let's start with the second part of our video where we will be focusing on connecting these two resistance pot to the black pill microcontroller using an ADC, where I will be using these pots to change the frequency and the duty cycle. And finally, I am using this logic analyzer here to check the duty cycle and the frequency. And this STM32 board, I am just using it as a debugger because this board doesn't come with an inbuilt debugger. So I am using these board debugger to debug it. Okay, so let's first understand how the pot will be connected and then we will proceed further. So here you can see that we have these two resistance pot, correct, and this one is the one which we are having on the board. So how these pots are connected, basically what we have a complete long resistance. These two pins are the last two pins, so they are A and B if I say. And there is one pin that is, we can see C, which will be, when we rotate this knob, then this will move on this axis, it will vary on this axis, and we connect it to the ADC pin. So what happens, we give 3.3 volt and 0 volt here. So when we move this knob in this across this section, we will get a differential voltage that will vary from 3.3 volt to 0 volt. And based on this voltage signal only, we will be getting the counts for like 4096. This is for the 12-bit ADC, and we will be converting this count to the frequency part, like to get the frequency and for the duty cycle. So I hope up to it is clear that we will be connecting the third pin of the ADC, third pin of the resistance port, which is this pin, to the ADC part, and we will be getting a voltage in between 3.3 and 0. So 3.3 volt corresponds to 4096 and 0 corresponds to 0. And based on this count, we will be converting it into the frequency and the duty cycle section. Okay, so let's start with the coding section then. Okay, so now let's begin with the configuration for these two resistors. So first we will configure the ADC. So I need to select the two channels to connect these two resistors. So first I will be selecting IN1 and IN0. I am keeping PA0 pin as empty, or I am not selecting IN0 because I will be using this key for in this project for controlling when I want to initiate the transfer of the ADC value to the frequency generation. Okay, for that I will be using this pin. So I am not using IN0. So now let's do the configuration related to the ADC part. So we will be running the ADC at 12 bits, so it will give the count as 4096. Then we need to enable the scanning mode, scan conversion mode, and we will enable the continuous conversion mode also. Okay, now go up. So total number of conversions, we you have to make it to 2. Now the rank has become 1 for channel 1, and the 2 we need to select for the channel 2. So total number of cycles, make it 15. Here also make it 15. So here the configuration part is done. Let's save it. So we will be doing the ADC conversion in a polling mode. So let's go to our code and write it. So this, here the configuration of the ADC is done, and these are the configuration related to the two channels. But since we will be using the polling mode, we want to control which channel we want to poll for conversion. So we will be writing a custom code to do that. So let's write a custom code. So let's go to the user begin function. So void select channel 1. So this function should select the channel 1, and we write one more function to select the channel 2. Okay, and inside that we need to copy the code related to this one. So just be careful, we need to write the same, copy the same code, just one change. So for both the channel we want to keep the rank as 1. So make the rank as 1, and let's copy the structure, and let's copy the declaration part. So declaration and this part is done. So whenever we will be calling one of this function, the particular channel will be selected, and we need to make the conversion for only one channel. So let's go to our while loop and call the channel, select channel 1 function, then all underscore adc underscore start, and then all underscore adc. We have to pull for conversion, and timeout we give as 1000. Similarly, we should get the value. So now we should get the value of the converted ADC value. So we need to store it. Since we are having two ADCs, we make one integer array, say ADC value array of length 2. Okay, so we copy the ADC, first ADC value in the position 0. So hal underscore ADC or get value from ADC1 from position 0, and then we say hal underscore ADC underscore stop. So we need to stop the ADC before we start it for the other channel. So this is done for the first channel. Copy the entire thing and just call it for the channel number 2. So channel number 2 is called for polling, and only here you need to save it to the second ADC position. Sorry, it will be in the second position. Correct. So our ADC conversion up to this is done. I hope up to this it is clear. So what we are doing, we have two ADC channel. We are calling the first channel, then starting the ADC, then we are asking for conversion, and then we are storing the value in this ADC, in this array, at zeroth position, and then stopping the ADC and doing the same thing for the channel 2. So let's build the code and see if that ADC is working fine or not. Okay, so we have to flash it. Okay, let's go to live watch, and we add ADC value here. So let's play. So we are already getting some value. So let's change the register and see if we are able to change the value. Yes, it is changing, but it is getting from only one. Let's see why it is happening like that. This ADC is not working, but this one is working. Right, okay, fine. So we are doing something wrong. Let's see in conversion what we are doing wrong is channel 2 we are calling. Okay, We are storing in one, we are storing in two, and let's go to the channel 2 here. Channel 2, we are putting here rank. Okay, fine. Putting here rank 1. Okay, fine. Okay, so now we saw that our one of the ADCs is not working. So I think here we are doing a mistake. We have total number of conversion given as two, but we are doing only one conversion and then stopping it and then doing another conversion. So every time we are doing only one conversion, that's why we have to put in total number of conversions as one. So now let's build the code and debug it and see. Okay, so now you can see there are two different ADC values, and I will be changing. I am making one value as 4094 and other value as, let's say, 0. So we have two working ADCs, both the ports are working. So I will be using one ADC for frequency and another ADC for the duty cycle. Okay, so let's write the code for that. Now let's write the function to convert the ADC value that we receive into frequency and into duty cycle. So we have already two variables created, that is this duty cycle and frequency. This we will be updating according to the ADC value received. So we will be using the first ADC value to use as a duty cycle and the second ADC value to use as a frequency. So maximum frequency we are counting it now is 2 kilohertz and the duty cycle should be up to 100. So let's write the function to convert it. So let's say void update frequency and duty. So whenever we have there is a change in the duty cycle or in there is a change in the ADC values, we'll update the frequency and duty cycle. So let's first update the frequency. So frequency is the float. So final calculation should be converted into the float, and what we need to do is whatever value we are receiving over ADC, we have to directly convert it to the frequency. So maximum value we can receive is 4095. So let's say the value what we receive from ADC, we are storing it into this array. So we will be using the second value in the array, and we multiply it with 5 and store it as a float in the frequency. So why we multiply with 5? So the maximum value is 4095, and if we multiply with 5, so the frequency comes somewhere around 2420475, something around that. So which we can say that it is approximately equivalent to 2 kilohertz. Okay, so we will be generating 2 kilohertz frequency at maximum. Now let's do the conversion for the duty cycle. So for the duty cycle, we have to maximum go up to 100%. So that also has to be converted into float. So let's first convert the ADC value into float that we receive. So here we will be using the first ADC value at index 0. So that ADC value is converted to float. Then we divide the converted ADC value by 4095.0, and finally we multiply the entire thing with 100. So this will give us the percentage. So if 4095 is received, then we have the 100%. If anything less, then we need to convert it into the percentage. So let's do the declaration part. Sorry, the .h file, and in the main part, let's call it just after the polling conversion is done. So we call it here. Let's build the code, flash it. Okay, I have added frequency and duty cycle already. So let's run it and see. Okay, we are already getting some value in frequency and duty cycle. So the corresponding ADC values are being converted. So I can vary it. So let's vary first the duty cycle. So we can make the duty cycle go all thing up to zero, and we can go as high as 100%. Okay. Similarly, we can vary the frequency. So frequency is currently some 11 kilohertz. Now we can go up to, I think, 20 kilohertz. Sorry, there I told it will be 2 kilohertz, but it can go up to 20 kilohertz. So now we can reduce the frequency also. Okay, so this will be the frequency. So now we have frequency and duty cycle controlled using these two resistance port. So now we write the code to use this frequency and duty cycle in our already defined set frequency function. So let's remove the set frequency function from here. Okay, let's give a initial starting like set frequency. We pass frequency and duty cycle. So initial frequency and duty cycle will be taken here. So our frequency generator will start with initial duty cycle and frequency. So what is the initial duty cycle and frequency? 2000, 2 kilohertz and 25. So it will start with 2 kilohertz and 25% duty cycle. Okay, so now we will, after updating, we have to call the set frequency function with the new available frequency and duty cycle. Okay, so here we have one issue, that these is a fluctuating value and we don't want to always keep on setting the frequency and duty cycle. We only want to set it whenever we require to, whenever we press a button. So I will be using this key button here to set it. So for that, let's define a GPIO input. So this onboard button is connected to GPIO pin PA0. So I will put it into GPIO input mode. Okay, and under GPIO, go here and select pull up mode. So by default it is pull up. You can look into the schematic of this board. So save it. Okay, so now let's write the a simple if statement to just check if that pin is low or not. All. So why I am checking low? Because it is by default high. GPIO read pin. So it is GPIO a comma GPIO underscore pin underscore 0. So if it is equals to 0, then only we want to set the frequency and duty cycle. Okay, and let's add a halt delay so that we don't keep on running the loop. So we add a delay of, let's say, 100 millisecond. So up to this, we are getting the ADC value, storing it, updating the duty cycle, and only setting the frequency, output frequency, whenever we are pressing the button. Okay, so I hope this part up to this is done. Let's build the code. Okay, flash it. Okay, and now for this portion I will be using the logic analyzer also. So where we will be checking if the logic analyzer output is matching with the output of our frequency generator. So let's start it and let's first see. So we are getting some frequency. Okay, this is the initial frequency, that is 2 kilohertz and 25% duty cycle. So now let's vary the frequency to, let's say, 1 kilohertz. Okay, somewhere around 1 kilohertz. Okay, and 1 kilohertz. Okay. Okay, and this to 50% duty cycle. Okay, okay, one problem we are facing again. Okay, I think the problem is when we did the configuration of GPIO, this got updated to 2. We need to make it 1, then debug it, build and debug, start it. Now let's change it to 1 kilohertz, to 1 kilohertz. Okay, and this one to, let's say, 50% duty cycle. Okay, and now let's see what is the value in here. So it is still 2 kilohertz and 25% duty cycle. And now let's press the button. Okay, so there is a change. So now the duty cycle, now it is changed to 1 kilohertz, and the frequent and the duty cycle is 50%. So it is matching with what we are setting here. So let's do it again. Let's keep it running. We set it, we set it to, let's say, 3 kilohertz, and some 70% duty cycle, and press the button. Maybe something here we need to change a bit. Okay, 1800. Okay, okay, some issues we are getting, so let's resolve those issues. Let's do one thing. Let's So we are getting issue when we are setting the frequency. So we are getting frequency. If we go here, it is directly being converted here. So what issue we are getting? Let's see. So let's do one thing. We make it integer. This one also integer. Finally, we convert float here. So float carry q1 is to float carry q1 dut by 1. So float 1 float dut. Okay, and here we have to pass integer. So let's go up here and convert it to integers. This also int. Okay, maybe okay, fine. Here also pass int integer. Okay, now let's see what happens. Okay, we need to also update here. So this is integer and this one is integer. Okay. We are getting FRE Q. We have to do FRE Q. Think now let's build and check. No error. So if I press now, okay, it is getting changed now. Okay, so let's see how much it is now. So it is matching. We have said 1.865 and 70% duty cycle. So it is working now. So let's change it again. Let's change it to 2.6 kilohertz and some 60% duty cycle and press it. Yes, it got changed now. So now it is working 2 point some 5 kilohertz and 60% duty cycle. So this is matching. So sometimes you will get an issue. You need to check what why this issue is coming. So I fixed it with integer. So I think there is creating some problem when we are passing this calculated frequency value as a float value directly. So just putting an integer is solving the issue. So that's how we can do. So yes, so we will see the part of how to use the screen. So currently the screen is blank. So in the next video, in the part 3, we will be using the screen for showing the exact frequency value that we are getting and finally setting the frequency value. Yeah, so please subscribe the channel and follow for more such videos. Thank you.